Advanced Financial Modeling, Topic 7, Option Valuation and Hedging, Learning Objective number 5. We want to understand and estimate GARCH volatility. It's another model to estimate standard deviation. So let's talk about EWMA one more minute. What are the advantages of EWMA over just, say, a full sample volatility or a subsample volatility? Unlike trying to choose a subsample volatility to be the best guess of future vol, it uses all the data. You don't have to choose, I want to use the last 20, 50, 100 days of volatility. It also matches the empirical observations of volatility clustering, meaning that the EWMA model uses the more recent data more heavily in the estimation of volatility. And it can be used to forecast, say, short-term volatility, say for the next few days or weeks. Here's the disadvantage of EWMA. It doesn't incorporate empirical findings that there's a long-term mean reversion in volatility. So what does that mean? Say this is a graph of volatility, and it's been well, let's say it's kind of in this range here and then spikes up. EWMA is going to forecast that new value, EWMA, or that new level of volatility is going to persist. However, there's finding that even though volatility may persist in a higher level, it's more likely to go back down to a more close to its long-term average volatility. So we have volatility clustering, big days expected to follow big days, but in the long run, it'll probably go back to its long-term average. So that's the concept of volatility clustering with long-term mean reversion. So GARCH is a model that is basically EWMA with a factor that incorporates mean reversion. And what it does, it basically forces your volatility estimates to go from an EWMA-like value to a long-term average. So if this is our data set, again, this is the Google graph of 20-day moving average volatilities, and the long-term average was 29%. EWMA gave me a number of 22. The problem with EWMA is, do I use that to price a one-day option, a one-year option, or a 10-year option? Because it only gives me one number, 22%. What GARCH is going to do, it's basically going to give you a similar number to EWMA, and if you're pricing a one-day option, maybe I'll just use that value. But if I'm pricing a 3-month option or a 1-year option or a 2-year option, it's going to force it back to the long-term average. That's the whole concept of GARCH. It uses the more recent data more heavily, but then forces it back to the long-term average. Here's our GARCH model, sometimes called the GARCH 1-1 model, and that is estimating variance for a particular day. And it's going to be some weight gamma times the long-term average V plus some weight alpha times the yesterday's return squared. Remember, that's basically just yesterday's squared deviation from the mean, plus beta times the estimate of GARCH the prior day. So again, gamma times the long-term, gamma times the long-term average, alpha times what happened yesterday, plus beta times the estimate the prior day. All right, and we're going to do a second stage once I do that, but let's go to the spreadsheet to understand what that means. So here's my lambda of 0.94 and my estimate of volatility of 22.28 for EWMA. Now I'm going to have a GARCH model where I'm going to set alpha equal to 6% and beta equal to 94%. All right, so alpha equal to 6%, beta equal to 94%, and I'll put 0, the weight on the long-term average, I'll make that 0 to say, what if we say that the long-term average has no effect? Well, I'm going to plug in my formula there, the one I just gave you. That is my alpha times alpha, the 6%, times D14, that's what happened yesterday, plus beta times the formula right here, but the day before. So it's the prior days, it's the lag days estimate using this formula, plus gamma, which I've currently set to 0, times the long-term variance of 0.03. That's actually the 29% long-term standard deviation, but the formulas I gave you are for variance. So that's the formula, and I just copy it down. all the way to the bottom of the data set, except I have to stop one day before the end, and I'll show you why. Here's that formula, right? Alpha times the prior day plus beta times the previous day. I'm sorry, alpha times that current day's square deviation from the mean, beta times the prior day's estimation, gamma times long-term average. But I can't copy this formula here because it would be looking for a blank cell below it. So notice what I have to do for that very oldest, the oldest day is I say my best estimate, since I only have one observation, is just the square deviation from the mean, or just the squared return on that last day. Okay, you can see this is just the squared return from over here. Okay, so going back up to the top. This process of always looking back one day and every day looks back another day gives me my GARCH estimate. This is a variance, remember? So I'm going to take the square root of that and multiply times the square root of 252. And oh my goodness, look what happened. I get the exact same value as EWMA. Because the value of GARCH is that it gives you a weight to apply to the long-term average. I put a 0 in there. So EWMA, GARCH will give you an EWMA estimate as long as that beta is equal to lambda in GARCH. I'm sorry, in EWMA, the GARCH beta is equal to the EWMA lambda. Alpha is 1 minus that, and gamma is 0. So what's this second part? So all this first part does is basically give you an EWMA estimate. However, I did have that weight on the long-term variance equal to 0. The real advantage now to GARCH is the second stage. It says when I'm forecasting in the future of a variance, say 1 day in the future or 2 days in the future, here's my formula. It's going to be the long-term average plus alpha plus beta to the I period, say 1, 2, 3 days in the future, times the difference between the the forecast sigma 2t, so the GARCH estimate that day, the prior day, minus the long-term average. So again, this is your GARCH estimate prior day. So what this formula does, it basically just forces the GARCH estimate back to the long-term average. So as long as there's a difference between the long-term average and the GARCH estimate, this forces it back to that average. So let's take a look at that formula. And here it is here. I say that I carry over that estimate we did from that first stage, and then I plug in the formula. Long-term average plus alpha plus beta to the I, and then the difference of the prior day's estimate and the long-term average. And I just copy that formula down. So this is the forecast of variance for 1 day from now, 2 days from now, 3 days from now, 4 days from now, and so forth. Now, what if I was trying to price the 13-day option? I would just take an average of these GARCH estimates for the last 13 days. And then if I take that to the square root and multiply times the square root of 252, I can use that as as a GARCH estimate for a 13-day option. But again, there's no long-term average here. So how can let me get some different values for this. I went to Bloomberg, and Bloomberg has used to have a tool that estimated the optimal factors for predicting GARCH volatility. What alpha, beta, gamma have done best to predict what the future volatility is going to be. And those values are given here. This is from a screen. Whoops. This is from Bloomberg. And what I got from that are, I'm going to use an alpha of 2.93, a beta of 93.61, and a gamma of 3.46. So I'll plug that into my spreadsheet. I'll put in a 93.61. I'll put in a 3.46. And there's the 2.93 because they have to all add up to 1. When I do that, Notice my GARCH estimate for the first day changes. And these all become different because what this is doing is this is saying, okay, based on those parameters, my estimate for the current variance is 0.0268. However, these formulas are forcing it back to the long-term average. And remember that long-term average is 0.033%. So, and if that 0.033% on an annualized standard deviation, by the way, is 29%. So if I'm pricing a 13-day option now with those parameters of the alpha, beta, and gamma, I now get a 27.78. If I were to price a 100-day option, notice I just take an average of 100 days estimates of GARCH, and it gives me 28.98. If I were to price a 200-day option, it's almost 29. So this is what's happening. GARCH has given me an estimate for volatility that's similar to an EWMA value for short-term options. But if I want to price longer-term options, it's going to force it back more towards the long-term average. And if I were to graph just those 3 points, I get this upward sloping curve, which tells me that it's predicting an upward sloping term structure of volatility. So GARCH allows us to understand how we could have upward sloping and downward sloping term structures of volatility. It's upward sloping because vol has been low, and this model is forecasting it's going to go back to long-term average. So this is a good model. This allows us to match empirical findings of volatility clustering and long-term mean reversion and volatility. So that's GARCH. In the next topic, we're going to start hedging cash flows using options and forwards that we used in the last topic.